Jupiter's moon Europa is a fascinating world with a salty subsurface ocean. There is a sea on the moon Europa. In fact, Europa has twice as much water as Earth does. Europa has an ocean. Europa actually has twice the amount of water that Earth does. 71% of Earth's area is water, which is necessary for life. People on Earth see so much water all the time that it's hard to think why the rest of the solar system doesn't have the same amount, but that's how things really are. Many places have been searched for signs of water anywhere in our world. NASA just stated that the James Webb telescope has found not only water on Jupiter's moon Europa but also an ocean there. This amazing find has changed the way scientists think about all of space. Come with us as we learn more about this finding and how it changes the field of science. Jupiter isn't like other planets. It's one of the most interesting big planets in the solar system. Being almost 11 times bigger than Earth, it stands over us with a diameter of 143,000 kilometers. To give you an idea of how huge Jupiter is, its volume is thought to be over 1,431 times bigger than Earth's. In fact, it's so big that it's larger than all the other worlds in our solar system put together. This also means that it has a strong gravitational field, pulling more than 2.5 times stronger than Earth's. It is important to be aware of Jupiter's gravity pull, with a gravity of about 24.79%. Which shapes its changing atmosphere and interesting weather patterns, such as the Great Red Spot and its famous bands of clouds and swirling storms. But Jupiter's huge number of moons is one of the most interesting things about it. There are an amazing 80 moons of Jupiter, and 57 of them are officially accepted by scientists. The International Astronomical Union still needs to identify and name the other 23 moons, but they will soon be official moons too. Jupiter has many moons, but the four biggest ones are especially important. Io, Europa, Ganymede, and Callisto are the Galilean moons. They were found by Galileo Galilei and Simon Marius separately in 1610, which was a major event in the history of science. People are interested in the Galilean moons because they are both historically important and quite large. Their mass makes them bigger than even the known dwarf planets, making them some of the biggest objects in our solar system. Europa and Ganymede, the two closest moons to Jupiter in the Galilean group, have an interesting orbital interaction with each other. This means their orbital periods are in a harmonic relationship, with Ganymede orbiting twice for every circle of Europa and going around 4 times in the same amount of time. In a way, this makes Jupiter's moon system sound more harmonious. Jupiter has more moons than just the Galilean group. It is thought to have about 100 irregular moons with diameters greater than 1 kilometer and another 500 smaller backward moons with diameters as small as 0.8 kilometers. Because their own gravitational pulls are smaller, these irregular moons often have irregular shapes. This shows how varied Jupiter's moon family is. Each of Jupiter's moons is different in terms of size, composition, and geological traits. The biggest moon in our solar system is Ganymede. It is a real giant among moons, and its huge size makes it an interesting place to study and visit. But things get even more interesting with Europa. In the world of science, Europa is very important because it is the 6th biggest moon in the solar system and the 4th largest moon of Jupiter. Europa has a very smooth surface, which is one of its most interesting qualities. The surface is so smooth that it is the smoothest of any solid body in the solar system. While most planets in the solar system, like Mars, have rough terrain and interesting traits, Europa's surface is remarkably smooth. It does have a few very tall hills, but the tallest ones are only a few hundred meters high. This subtle rise adds to the soft beauty of Europa's surface, where big craters aren't common. This suggests that the moon's geological past has been active and changing over time. Europa's spin is tidally locked, which means one side of the moon is always facing Jupiter. The gravitational pull of two stellar bodies makes one side of a moon always face its parent planet. This is called tidal locking. Europa spins on its axis so that the same side of the moon always faces the gas giant Jupiter. This is different from Earth's moon, whose side facing the sun changes over time. Because of this phenomenon, Europa has a unique climate. One side of the moon is always facing Jupiter, which makes the surface conditions very different on the leading and trailing hemispheres. When Europa moves around Jupiter, the leading hemisphere faces the direction of motion and feels stronger tides. The trailing hemisphere, on the other hand, faces away from the motion and experiences weaker tides. The tides that Jupiter generates cause Europa's core to bend and deform. These tidal forces stretch and squeeze the moon, creating heat inside it. This process, known as tidal heating, is a key factor in keeping Europa's geological activity ongoing and shaping its unique features. Compared to Earth's moon, Europa is a little smaller. It is thought to have a stacked structure with an iron core, a rocky mantle, and a massive ocean of salty water below its icy crust. A surprising discovery: the depth of this ocean below the surface is estimated to be between 40 and 100 miles, which is many times deeper than Earth's seas. Europa's subsurface seas are thought to hold an incredible amount of water, about twice the volume of all of Earth's oceans combined. As we all know, water is an essential ingredient for life, making Europa's vast ocean a significant area for further study and exploration. Scientists have gathered evidence for this ocean through observations and studies across different fields. Data from the Hubble Space Telescope and later the James Webb Space Telescope strongly suggest the existence of a global ocean beneath Europa's icy surface. Spectroscopic data has been crucial in understanding Europa's composition, surface, and its connection to the ocean below. By carefully analyzing the light Europa reflects or emits across a range of colors, researchers can learn more about this intriguing moon. This gives scientists useful information about the chemical and physical makeup of the moon's surface. When scientists carefully look at Europa's spectral fingerprints, they can tell that the moon's surface is full of water ice. A key part is water ice, which shows how much frozen water there is in the form of ice crystals or ice grains. The discovery of water ice is important because it suggests that there is a source of water that may go below the surface. Spectroscopic tests have shown that Europa's surface has more than just water ice. It also has salts. People think that these salts came from the ocean below, but they could have been brought to the top by processes like cryovolcanism or geological activity. Besides that, spectroscopic research has also shown that Europa's surface has organic molecules. Organic molecules are made up of substances based on carbon and are the building blocks of all living things. Why is it so important to learn about the unique spectral fingerprints of different materials? That helps scientists learn more about the surface of Europa, including what it's made of, where it is located, and how it behaves. They can figure out how common different chemicals are and how their distribution changes over space. Spectroscopic readings are usually taken by instruments on spacecraft that pass by Europa or orbit it. Scientists can get detailed spectra that show the unique fingerprints of different materials by looking at the reflected sunlight or heat emissions from the moon's surface. Then these measurements are compared to theoretical models and experiments done in the lab to figure out what the materials on Europa's surface are made of and how they behave. Yes, but that's only the beginning. Important information about Europa's magnetic field has also come from spacecraft efforts like NASA's Galileo mission. This adds to the evidence of the ocean. The results of these tests show that there is a magnetic field around the moon, which suggests that there is a conductive fluid inside it. The most likely explanation for this conductive fluid is an ocean of salty water that reacts with Jupiter's strong magnetic field to create the magnetic signature that can be seen. Scientists have looked very closely at the magnetic field strength, direction, and changes over time to figure out how deep, wide, and salty the ocean might be. It also gives us information about how the ocean moves and changes over time, like whether there are currents and how they interact with the ice shell above. Besides all of that, magnetic field data can also help scientists figure out how the moon works and what structures are inside it. It provides information about the conductivity and makeup of the materials below the surface, which helps us understand how the ocean and Europa's rocky core are connected. The readings of the moon's magnetic field also help us learn more about its geophysical activity, like tectonic movements or hydrothermal vents, which may be caused by the ocean interacting with the moon's interior. And that's not all. Thermal devices and sensors are also very important for studying Europa's surface and figuring out how warm the ocean below is. These cutting-edge tools are needed to record heat signatures and watch how temperatures change, which in turn gives us useful information about the complicated energy transfers happening between the vast ocean and Europa's icy crust. By measuring these thermal qualities in great detail, scientists can improve their models and learn more about how heat moves and stays stable inside Europa's unique planetary body. With the help of these detailed thermal readings, we can get a better idea of the constantly changing processes going on below the surface of Europa. We can learn more about the ocean by using surface imaging and mapping. Scientists can get a good look at Europa's surface by using improved high-resolution imaging techniques and accurate mapping methods. Researchers are learning more about the complex fractures, ridges, and other geological features that might hold important clues about the water by carefully examining these detailed pictures. This is an important part of mapping the mysterious scenery of Europa. Scientists can create detailed maps that reveal the secrets of the deep ocean by carefully documenting and drawing where these rock formations are located and how large they are. With each new picture taken and geological feature found, it becomes easier to understand how the moon's complicated interior works. But that's not the most important thing here. Imaging and mapping the surface are crucial for finding places that future exploration missions might target. Our current focus may be on using tools like the James Webb Space Telescope. However, in the future, robots or even humans may make it to the surface. And that can't happen until we know everything we can from afar. Scientists can choose which areas are most important for further research by learning about them. For example, they can learn about places where there is active geological activity or where the icy shell may be thinner. These images will guide future missions to Europa. NASA is already preparing projects that will be sent to Europa to learn more about it. NASA's Europa Clipper is one of these much-anticipated projects. The goal of this groundbreaking journey, set to begin in October 2024, is to learn more about Europa. Its major task is to determine if the underground ocean could be a place where life could exist. The spacecraft will orbit Jupiter instead of Europa itself, making careful maneuvers to perform about 40 to 50 close flybys of Europa. By adjusting its flight path for each encounter, the spacecraft can scan nearly the entire Moon and collect accurate readings and data. Scientists on the Europa Clipper project aim to assess whether conditions on Europa could support life. The mission isn't explicitly designed to find life itself, but it will identify places beneath Europa's icy surface where life might survive and thrive. Experts are confident that there is an ocean of liquid water below Europa's crust. The spacecraft will conduct an extensive study to determine if the Moon can sustain life. Equipped with a sophisticated scientific payload, the Europa Clipper is prepared for an in-depth investigation. It will carry a suite of high-tech instruments designed to gather crucial data and pave the way for deeper studies of Europa's surface and interior. These tools will take precise measurements, examine the Moon's magnetic field, analyze surface temperatures, and assess the composition and thickness of the icy crust, offering a comprehensive view of Europa's fascinating features. The Europa Clipper will fly by Europa 44 times over its 3.5-year mission at altitudes ranging from 25 to 2,700 kilometers. Each pass provides scientists with an opportunity to gather vital data and learn more about the Moon's habitability, sometimes from a completely new perspective and other times to build on existing information. With the knowledge gained from this mission, scientists hope to uncover what lies beneath Europa's icy surface and deepen our understanding of this intriguing object in the solar system. The Europa Clipper project holds immense potential to advance our understanding of habitable planets in our solar system and answer profound questions about life beyond Earth. There might be a hidden ecosystem beneath the ice, but we'll have to wait for the Europa Clipper to reveal the truth. What do you think? Is it really possible? Write your answer in the box below. Please give this video a thumbs up and subscribe to our channel to see more content like this. See you in the next one.